Welcome, guys. So this video, we are just trying to give a very easy application, 3 applications of the Gauss of the Gauss law. Okay, so everybody knows about the integral form of the Gauss law. Basically, you plot the Gauss sphere, you plot some sphere S and then close, and all the electric field among this sphere with integral along the S will be the rho divided by will be the total charge divided by epsilon. So total charge is a closed charge. It's all the charge inside here for the electric field. Okay, and then we can use this to solve 3 simple configuration. Okay, so let's start. So the first is basically a single charge, or other like or basically any charge. So if you have a single charge Q, then the simple is that you can, or you have a sphere. You have a sphere with the uniform charge Q, then you can take the radius R, right? Sphere, and from symmetry, then all the electric field among the surface is the same. So you have E ds. S will be just E times 4 pi R squared. Then you will be Q divided by epsilon. So the famous result is Q divided by 4 pi epsilon R squared. So this is the electric field, and if you want to write in the vector form, then you just write it as this. This is our head. Okay. I think there are various. Okay, and the second is that if you have a line, right? You have a infinite line with charge density lambda, and then you take a Gaussian surface like this, then the electric field among these will be these directions. Okay, so you get E times, suppose this is R, the height is H, you get E 2 pi R H will be the total Q, right? Total Q will be lambda times H, right? Lambda H divided by epsilon. So this is the line charge density, right? So E will be H will delete, E will be lambda 2 pi R lambda 2 pi R epsilon. So you see it's one dimension, it's 1 over R, and then if you want to write the vector form, you just write it as this, and the R hat is these directions. Okay, so this is the second application, electric field of a single of the infinite lines. Okay, and the third is basically the easy way, right? So easy. So basically, you have an infinite large charge, infinite charge plate, and you want to find an electric field here. So this is electric field. This is electric field, and the area is A, right? So you have 2EA, right? 2A is so this is the electric field. You will go outside these directions. Okay, so 2EA equals to Q divided by epsilon, right? Epsilon naught. So Q, what is Q, right? So Q is supposedly charge density for among areas A. If lambda, you get lambda A. So E will be lambda divided by 2 epsilon. And then for the upper, it should be Z hat, right? And then for the lower, should be minus Z hat. So suppose this is Z directions. Okay, so these are very easy 3 applications of the Gauss law. And the next things, maybe we can prove the Gauss law, and I will see you guys in the next videos.